Hello everyone. In this lecture, we'll be viewing about some other transformations like reflection and shearing. So in the last video, we saw three of the main transformation techniques like translation, rotation and scaling. We saw rotation and scaling with respect to origin, rotation with respect to a point, and scaling with respect to a point, and scaling with respect to another axis which is not the coordinate x and y axis. So now we'll see what is reflection. So as I've already told you, reflection is just producing a mirror image. So if you take this triangle 1, 2 and 3, and so after reflection, this becomes 1 dash, 2 dash, 3 dash. So this 1 dash, 2 dash, 3 dash is the reflected position of this original position. So there is reflection. Reflection has many types actually. So reflection is about the x-axis. First, let us see reflection about the x-axis. A reflection about the x-axis actually means the x-axis acts as the mirror. So let x dash y dash is the new coordinates and where xy is the original coordinates. If you see in reflection about x-axis, the x coordinates remains positive but the y coordinates become negative. So it comes below the x-axis. It is below the coordinate x-axis. So x dash is x but y dash becomes minus y. So that is what is expressed in this matrix. X dash equals to x and y dash equals to y. So the next is reflection about y-axis, in which the y-axis acts as a mirror. If you see carefully, the y coordinates remain positive but the x coordinates changes its sign. If it is negative, it will become positive. If it is positive, it will become negative. So the x dash will become minus x and y dash will become y. If you see, there is no movement of movement of any object, but if for example if we take 2 comma 3 and if we want to reflect that on x-axis, it will become 2 comma minus 3. That is, only the y-axis sign changes but the magnitude remains constant. The next case is flipping with respect to both axes, or this case can be also said as reflection with respect to origin. So in this case, what happens is, if it is in the first quadrant, it will come to the third quadrant. If it is in the second quadrant, it will come to the fourth quadrant. So both x and y axis sign will change. So x dash will become x and y dash will become y minus y. So this is the matrix for that. So x dash will become minus x and y dash will become minus y. Then the fourth case is reflection about a diagonal line y equals to x. So if we draw a line y and x, y equals to x, so what happens is that the x coordinate after reflection will become the y coordinate and the y coordinate after reflection will become the x coordinate. So if you see carefully, so this is the matrix. The x dash will be equals to y and the y dash will be equals to x. So see, this is the equation that is given. That happens when if you do reflection about the line y equals to x. So if you do reflection along the line y equals to minus x, what happens is that x coordinates will become minus y coordinates and y coordinate will become minus x coordinate, just like reflection about x equals to y, but it will inherit a minus and a minus sign also. So that is, this is the matrix for that reflection about the diagonal line y equals to minus x. See, this is the equation that is given. X dash equals to minus y, y dash equals to minus x. So the last transformation that we are going to see is shear transformation. So I tried to explain you the shear transformation. If you did not understand previously, now there is a diagram in which you can understand properly. This is the object before shearing. Consider that this object is stuck to the surface with some glue. Okay. Now, when you apply shearing transformation, you can see that the object, the side which is stuck with glue remains that, but the object has moved to slant. I can say it has slanted slightly. So, the slanting from its original shape to its new shape, this is known as shearing. Okay. So, there is shearing parameter x, shx, and also there is a shearing parameter shy. So let me explain you shear with respect to x. So if you do shearing with respect to x axis will move but y will remain constant. So x dash equals to x plus y into shx, sorry, y into shx, that is shear, and y dash will remain y. Actually this is not minus x, this is y. Y axis will remain as it is, but x axis will be sheared, that is x axis will be moved. So if you see carefully, this 1 will remain 1 and here also the 1 remained 1, but the x axis 0 has become 2 and here 1 has become 3. So this is x axis shearing. Similarly in y axis shearing also, the matrix will be x dash y dash 1. Here it will be here in this matrix it will be 0 1 0. Here it will be SHY 1 0. So the x will be multiplied by SHY in y axis shearing. In x axis shearing, y is multiplied by SHX. So this is what shearing is. Then now next we will see transformation between two Cartesian system. So in the original Cartesian system we are using this x and this y axis. Suppose if the object is using a different Cartesian system like this x dash and y dash axis, then what we will do, this technique is similar to that of what we used in composite transformations. So what we do actually is we rotate this object in which direction? Clockwise direction. So the theta will be minus such that it is in parallel to this any one of the axis. Either it should be y axis or x axis. For now let us take x axis. So now we will rotate this this new coordinate clockwise direction so that it comes parallel to the x axis. Then we move it to the origin. Okay, we move this origin of the new coordinate system to the original coordinate system. So that is what is done here. So if you see, there is a clockwise rotation matrix, if you see carefully, and then there is a negative translation matrix. So the translation is done. But what is first applied is, first we'll move this to the origin, then rotate. So that is why I told you, right, what is the first transformation is applied, that will come as in the right hand most side, then followed by going towards the left. The last transformation will be in the left hand most side. So before we complete this session, we have completed a translation, rotation, scaling, shearing and reflection for 2D. That is 2D transformation is completely finished. Now we'll go to the next topic, two-dimensional viewing. So I told you viewing is a very important thing. So let us read this paragraph and understand. All the objects in the real world have some sizes, but that size will not be exactly perfect when we project it in the computer. So that transformation from the real object into screen coordinate system. So this transformation of the real object into screen coordinate system is known as viewing transformation. Okay. So next is windows and clipping. So what is it? What is window and viewport? We have to understand what is window and viewport. Window is nothing but if an object is there. For example, take this entire screen as the world coordinates. So world coordinates by means I am saying that this is the entire screen that will be present. But in this screen, I just want this clipping word. So this blue box, can you see this blue box? That will act as the window. So what is inside this blue box will be presented, and what is outside this blue block will be clipped. So that will not be present. So this blue box has its own coordinate. So this is the x coordinate, this is the y coordinate. This coordinate of the window or the window coordinate is known as the world coordinate system. So a window is a rectangular region in the world coordinate system. So if this is the world coordinate, a window is just a rectangular region. So this clipping, if I mark this clipping, you can see a rectangular region surrounding this clipping, right? So this is the window. And what is viewport is, if I want to move, if I want to select this and move, I cannot move. But in viewport, I should be able to select this and move anywhere where I want. See, once I've clipped the once I've selected this window and clipped it, the rest, all these things will be vanishing because it's outside the clipping window. Then I can move my window anywhere. So that is known as viewport coordinate system. So we'll see properly with an example. So think this as the entire screen, and this image is there in the x and y coordinate. Now let us select a window. See, this is the window. So after this window is selected, a viewport is a section of a screen where the images compressed by the window or the world coordinate system will be drawn. Okay, so I'll see. So this is the after cutting, the window will be like this. So moving this portion here, see, this is the viewport. So this viewport can be here, the viewport can be here, the viewport can be here. So it is nothing but moving first window. This is the image. The window coordinate clips the image. Then the rest will be clipped, that is the rest will be hidden, eliminated. Then this place, this window can be presented anywhere in the screen. That window will be known as the viewport. So this will be the viewport. Okay, I hope you understand. I understood what is the difference between. See, when a window is placed on the world, only certain objects of the parts of the objects can be seen. See, like that fish image, you can see only certain part of the object. The points and lines which are outside the window are cut off from view. This process of cutting off parts of image of the world is called clipping. So this is one of very important definition in computer graphics. Clipping is very important technique also, and we'll be using clipping throughout our study in the second and third unit fully. So now you understand what is clipping, right? So the points and lines which are outside the window are cut off from view. This process of cutting off the parts is known as clipping. So this video is over, and in the next video we'll be seeing techniques of clipping like line clipping algorithm. We'll be also seeing polygon clipping algorithm. So thanks for watching this video. I hope you understood everything. Thank you.